This is how to graph or solve a system of linear inequalities. So you're going to have two equations and you're going to have to find out where the solutions are true for both inequalities in the system. You always look at the first and second equation. I always like to graph the first one and then graph the second one. I have to look at the sign and identify if it's going to be dashed or solid. So in this case, this one is going to be solid because it's greater than or equal to. So I like to label that. Then I'm going to use these two numbers. So -1 is my slope and 4 is my y-intercept. So what I'm going to do is I'm going to start at 4. So 1, 2, 3, 4. Okay. And then I'm going to go down 1 to the right 1 using my slope of -1. Same thing up to the left, up and to the left, and I'm going to draw a solid line. Now for this one, when I use my solid line, I'm going to now determine which way to shade. And how I do that is because it's greater than, I'm going to shade above. But if I'm not sure if that's the correct way to do it, I'm going to try a point either to the left or right of the line. Now in this case, 0, 0 is on the left or right. So if I did 0, if I put that in for y, is greater than or equal to negative times 0 plus 4. So is 0 greater than or equal to 4? That is false, so I shade on the opposite side of 0, 0. Okay, now I'm going to do the same thing for the line, the second line, or second inequality. And notice this is not in y equals mx plus b, so I'm going to solve for y, negative x plus 0. I divide by a -1 to get y by itself, and because I divide by a negative, I have to flip the sign in the inequality. So I have y is greater than or equal to, this is going to turn into 1x and then 0. And so I don't have to write anything. So that means I'm going to start on the origin. I'm going to go up 1 to the right 1 and so forth. I keep going all the way through. I'm going to go down. And then because this is a greater than or equal sign, it's going to be solid. And then because it's greater than, I want to shade above. And in this case, I could also check and I could put a point to the left or right of the line. Let's try let's try -1, 0. So if I put -1 in for x, put 0 is greater than or equal to -1. And that's true, so I'm going to shade above. So my solution is now going to be at the point where they are crossing. This wouldn't work because this would only be true for the bottom equation. This section right here would not work because it would only be true for the top equation. This section would not be true. None of these points would work because it doesn't help out or make either of the inequalities true. This is the only section where it makes it true. So let's go to the next one. I want to start at, this is going to be a dashed line because it is greater than. I'm going to start at -3. I'm going to use my slope, so I'm going to go up 2 to the right 1. Same thing, down 2 to the left 1. That still makes it positive. And I want to make sure it's a dashed line. Because it's greater than, I'm going to shade above. So this is above the line. And then that would be done for that inequality. I'm then going to go to, this is greater than or equal to, so this is going to be solid. So I'm going to start at +1. I'm going to go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. I'm also going to go down 1 to the left 2. and keep going. I'm going to make it a solid line. And because it's greater than or equal to, I'm going to shade up. Now, the only section that's going to be true is going to be this part right here. This is where if you plugged in any point into these inequalities, it would remain true, both of them. This section would only make the bottom one true. This section would make neither of these inequalities true. And this section would only make the top one true. So let's try one more. That's going to be this one. So I'm going to start with, this is going to be dashed because it's a greater than symbol. I'm going to start at 2. I'm going to go up 2 to the right one because that's my slope. I'm also going to go down 2 into the left one. And it's going to be dashed. Now I want greater than, and if I wanted to, I could try a point to see if it works. Let me try 0, 0 because it's on the left or right of the line. So 0 is greater than 2 times 0 plus 2. So is 0 greater than 2? That is false. So you shade on the opposite side of 0, 0, or you notice that it's greater than, so you shade above the line. So now I shaded above. And this next one is a y equals a -1. So I would start, this is going to be solid because it's a greater than or equal sign. I start at -1 and I want all points that make y equal to -1. And that's going to be a horizontal line. So all of these points have a y value of -1, solid. And it's greater than, so I want to shade above the line, but I could prove that. So if I put in 0, 0, 0, but I only have to use the y coordinate for 0. So 0 is equal to -1. That's true, so I'm going to shade up. If it's a less than symbol, you would have shaded down, but because it's greater than, you shade up. So where they are common is going to be this section right here. This would be your solution.